Yeah. Hmm. Okay. So, in this string, um, like, I have a list of different new topics that I need to solve, and one of those, like, two of those topics are binary search and answer, and another one is meet in the middle algorithm. So I have learned, like I've watched YouTube videos for both of these algorithms and like the daytime, uh, and like they are very nice algorithm to be honest, and very easy also. And yeah, like I don't know, like if I can show those videos, yeah. Let's see. What we can do is, yeah, like I will try to take some screenshots. That would be good, I guess. I don't know. Yeah, like I can take some screenshots to refer, but so I've referred this video, and this is very nice video to learn the meet in the middle algorithm. But we will just take a screenshot for it. Okay. So, um, we have these two chats in which I have shared the screenshot, and there is a detailed explanation for all those code. So these are the two algorithms. This is mid and middle algorithm, and this is the we can say that binary search on answer algorithm. There are some specific cases. For example, binary search on answer algorithm is similar to binary search, similar to binary search. ठीक है? But can be used on unsorted array. The array that we use the binary search need not be a sorted array to use this algorithm. And in general, there is always a always a check function that decides whether to move the left or like the high pointer or low pointer, um, like after or like before mid. Okay, which determines the new position of high and low pointers, which determines new location, new location of low and high pointer. Okay, and like the check function will be of bool type. So um, every time, like for example, there is a question: Coco eats banana. Lead code. Okay, so like we can say this. Um, this is the problem, and yeah, like I've previously solved this question, but without without knowing what is um this algorithm, and likely I have used GPT to like help me. I couldn't think this question on my own, but this is the problem, and this is the solution. Okay. Okay. So like we need not. Okay. So like there is very similar code here, similar to the binary, like the OG binary search. Like we have a start pointer, we have a end pointer, but this is a slightly different solution than we have here. This is more of a generic solution. Okay, right? We have sorted this problem. Right, not this. This. Okay, in binary search and this is the Coco, right? Okay, this is another solution. Not the Coco ones. There is another question, but this one, this one. Yeah. So Okay. So here like we have the complete notes that is designed from um the previous chat that I have that I did with GPT. Okay. So binary search and answer is a different algorithm than binary search. Binary search needs sorted array to work on the solution, but binary search and answer doesn't require a sorted array. It has a special check function that returns a bool value. And based on that bool value, we will decide whether to move the lower high pointer uh, to like either side of the mid. Okay. Um, the like basic um, template for this algorithm is similar to the binary search. Okay. So the similar thing is said here, I guess. Binary search and answer is a technique where instead of searching in an array, we search over a range of possible answers. Okay. We use it when the answer is a number. We check the feasibility, and okay, the feasibility function is monotonic. So like this is the best and the like most important condition. Okay, the feasibility. Feasibility function means the check functions. Okay, feasibility. The feasibility function is monotonic. Okay, this means like for a certain or in a certain range of number, like we are getting like false, 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 but there is a breaking point and the false will switch to true, or it can be vice versa. There like in a range of possible answers, we are like in the range of possible numbers, we are getting true, 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 and at a certain breaking point there is a transition from true to false, and then we will get the false ones. Okay, so like we in general we are asked to like in general when we use this algorithm, we need to return that transition point, either the true or false value, not the false value, but the number on that value. That is like transitioning the monotonic behavior of the feasibility function. The feasibility function is the check function. Okay. When should you think of binary search and answer? Uh, there is a maximum or minimum possible value, kth largest or kth smallest value, or smallest value that satisfies a condition. In these kind of problem, ठीक है, we will use this BSOA. Okay, when to use minimum maximum possible values. Okay, kth largest or smallest value, or smallest value that satisfies a condition. Smallest value that satisfies a condition. Okay. um and we need to write a check function. Okay, and the check function is like like I told you before, the check function behave in a monotonic way. Like there will be a false, 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 and there will be a transition period in which the false turns to true or the true turns to false. Okay, if yes, then there will be a application, then that question will be an application of binary search and answer. This is a very like giveaway of any question to like use binary search and answer on this problem. Okay. check functions and check behaves like false, 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 true, true, or true, 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 false, false, transition. Okay, so this is the course structure, the general template. Okay, we have a low pointer and we have a high pointer, which is like the minimum, and this is not a pointer, this is like a low value and high value, and maximum answer and minimum answer we can store it in this, and this is a like general general code for a binary search algorithm that we define a mid, and instead of like uh, the basic the most general condition for like the used in binary search is like the using the greater than and less than equality with the key that is given in the problem. Here we will use a check function, and based on the check function we will define the high or mid, and high and low, and we will return the low. Okay, low is the smallest possible answer, yeah, and high is largest possible answer. Low, okay. The check function is the art of being this algorithm, that if I choose X as the answer, does it work? Okay, and okay, so like this is the solution for the Coco eats banana, and like, this is not the solution that the YouTuber gave in his video. This is that solution that he defined the low. The sorting is not required in this problem, as the monkey is eating every banana and he needs to finish all the bananas in that time. So it doesn't require to sort the array. And yeah, like in this problem, like here it is said key we have to avoid 1e9 in general for a solution, but yeah, yeah, never blindly use this, but yeah, like we can use max of pi. So yeah, so we have defined a low and high pointer and answer. Okay, so we define a mid here, and we will use a check function, and while using the check function we will define answer that this is the current answer, and we will try to find another answer if like any answer is less than this. If any answer is less than this, we will define we will give that as our answer, because we need to find the minimum value of k. Okay, okay, so like what with every answer defined, high is equal to mid minus 1, and if the answer is not found, then we will define low to the mid plus 1, and this is the check function. Like we define on hours at first, then we will iterate over the pile array, and we will just add the hours, and if like the yeah, so like this is very understandable. that why are we using this one line of code. And if the ours is greater than h, we will return false. Otherwise, out of the loop, we will return true. Okay. Okay. So like this is similar algorithm, and yeah, find the smallest distance t, pair with distance. Okay. Check the logic. Okay. So like this is another problem. We have to find the kth smallest pair. Um, kth smallest pair distance. The distance is given, I think. This is the problem. No, 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 not this one. What is the problem? Yeah. So like the distance of the pair of integer a and b is defined as the absolute distance between absolute difference between a and b given an integer array nums, an integer k. Return the kth smallest distance among all. Okay. We need to return the distance, the minimum distance between two numbers. Okay. So um in the check function, like the general function will be similar to this. Okay. And for the case smallest, the maximum will be, yeah, the maximum uh, distance will be the difference of the minimum and maximum. Okay, so high pointer will be this, low pointer will be 0. Okay, and we will define a mid, and we will check if the mid is um okay, we are defining a distance t that will be mid. Okay, and we are um taking the nums integer, and k will be like the kth smallest. Okay, so um we are seeing if we are like store the size of the array here, then we used int j equal to 0. This is the pointer. Okay, like the index, not pointer. Okay, and we have defined a count variable, and we are iterating over the array and checking if the nums, like the difference between uh, the current, we are fixing the I pointer, and we are moving the j pointer, and with every pointer, like with every element, we are checking if the element is like less than or equal to d or not. Okay. Okay, it's smallest there. Okay. We have to find we have to give the minimum distance. Okay. So we are checking if the distance is less than d or not. If the distance is less than d, we will just move to the next pointer, and we will add the count in that. Okay. So like to understand the second question, we can use previous chat. Okay. Okay. So this is the original code that that YouTuber used to solve this question. Like while iterating over the array, um, he pointed, he like found the maximum, uh, he found the position. Okay. So like while iterating over the array, he found the position of any number that satisfies the condition of the distance. Okay. And like from, like if we are at ith position, we will start from the next position and find if this um This plus distance is equal to this or not. I think this is the solution, right? No, 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 no. Like for every ith position, we are finding the upper bound of the value that is equal to nums plus I plus my distance. Okay, nums I plus distance. So like if the ith position is 1 and distance is 3, then we need to find a value of 4 and the upper bound, the last possible value 4 in the array, in the sorted array. Okay. So like maybe it comes here between like after skipping two elements and okay. So this is the pointer where the IT is pointer. IT is pointing. Then we will just count the number of elements from here to here, and if the count is greater than k, it means there are um like minimum the k smallest. Okay. How is k? Look, wait. What is the meaning of k smallest? Mm, like there are k elements in between these. The count is greater than k. That means okay. I think we need to see the diagram. Okay, I have understood this before, but what is count storing? Count storing the number of values. Okay, so we have this input 1346, k is 4. We need to find the fourth smallest difference. Okay, these are all the pairs, and so check 3 should return true. So initial state count is 0 and is 4. We move I equal to 0, and the upper bound we need to find is this. The upper bound will give the range search will be this, and upper bound 4 will points to 6. Okay. Indices num psi being plus 1, that will be 1. IT will be pointing to 3. Valid pair counts will be update 2. 2 is the number of pairs. The number of pairs are found by this. The final pointer minus nums dot begin plus 1 plus 1 plus I plus 1. Okay. There's so much text. I don't like this. Honest. Okay, so like this is the whole binary search. The only thing we need to find, we need to see is how they're updating the count, and this will like the check function will be different for every question, but the core question will be similar to everyone, every problem. Okay, we need to find the count pairs ij, array sorted. So we are fixing I and value j. Let's satisfy this. The array sorted, all j are continuous. Find j, let j first index. Valid index will be this. Number of pairs will be. अब ज़्यादा ही छोटा हो गया, टाइम करना पड़ेगा क्या? We can use the read aloud function.
This is a very important question, and I'm really glad you asked it. I'll explain it from first principles, not formulas. Once this clicks, binary search on answer plus pair counting becomes automatic in your head. We'll talk only about how we derived count equals j minus I minus 1. Set. Step 0. What are we trying to count? In kth smallest pair distance, for a fixed distance d, we want, open quote, how many pairs ij exist such that pis, close quote, you can see the code in our conversation history. That's it. Nothing more. Step 1. Why do we sort? After sorting, you can see the code in our conversation history. Now the distance simplifies. You can see the code in our conversation history. So the condition becomes, you can see the code in our conversation history. This is the key transformation. Step 2. Fix I. This is the mindset. Instead of counting all pairs together, we do this. Open quote, fix the left element I and count how many valid j exist for it. Close quote. This avoids double counting and keeps things simple. Step 3. What does the valid region look like? For a fixed I, you can see the code in our conversation history. Because the array is sorted, all valid j are contiguous. Once nums j, nums I plus d, no future j will work. Step 4. How do we find the last valid j? Using 2 pointers or upper bound. Let, you can see the code in our conversation history. So the valid indices are, you can see the code in our conversation history. Hash step 5. How many valid pairs for this I? Count of integers in. You can see the code in our conversation history. Formula, you can see the code in our conversation history. This is where count equals j.
Oh, this is not working. Okay. Okay, so like after reading all this text, I finally got how did they find this formula. And okay, so like binary search answer is not a big problem. Like first question is this. Okay, so one algorithm is done out of many. Now we are moving to the next algorithm, and that is it in the middle. And okay, so mate in the middle is like, for example, we have this problem. In this problem, we are given an array of n numbers, and in how many ways can you choose a subset of numbers with a sum of x? Okay. Um, so like we can also use different like dynamic programming can also be used with a similar kind of approach such as knapsack. But if we look at the constraint, and the constraint is very high, so like this is 10 to power 9, and then is 40. So the time complexity like operations will be 14 to 10 to the power 9. Yeah. Okay. Um, so like the main key to find if we can use this algorithm made in the middle or not is like finding the number of the size of the array. Like size of the array will not be very large, and like to find the sum at every location we need to just choose if we want to take that element in our sum or not. Okay, so at every position we will decide if we want to take one or not, if we want to take two or not, if we want to take three or not, and if we want to take two and not. So like there will be a tree like structure, and final um, combinations will be 2 to power n. That will be very large, considering n is um, 30 to 45 in the range of something like this. And the like value of 2 to power n will be around 1e12. That will be 10 to power 12. But if we like separate, if we like divide the complete array in two parts, and we will just solve half part in one time and half part in another time, then we will like divide this um, combinations in two parts, and the algorithm will be optimized. Okay, so like the meet in the middle cuts exponential complexity in half. Okay. Okay, so we have the, okay, so the mean like P to C is the size of the array that will be um, in this range. Going to use size of array will be approximately 30 to 45. Okay, so total combination will be very large if we just divide this algorithm. um, Divide array complexity using brute force to the power exponential exponential complexity cuts in half. Okay. Twist on twist on. Okay. So instead of considering all the 2 raised to the power n subset, split the array into half, generate all the subset sum for each half, and combine the result efficiently. Okay. Ayan. Steps. Split array in two halves. Generate all the subsets. For each half. Combine efficiently. Okay. So general like template will be given an array 0 to n minus 1 in target x. Okay. We will split the array into left and right. That will be 0 to n by 2 minus 1 and n by 2 to n minus 1. And we will generate all the subset sum of left in frequency 1. And we will make two frequency hash maps, and in that we will store the subset sum frequency in this and this. Okay, and we will just combine it in answer. Okay, so the subset sum generation key function, the recursive pattern most common. um we will just, yeah, like this is what I was talking about. We will just take and don't take something, and we will use a map, and in that map we will just make a frequency map. Okay. Okay, the left pointer will start from 0 to the left half, and from n by 2 to the right half. Never pronounce. So okay, we use the two data structures here. One is frequency map, which is like generally the ordinary unordered map, used to count the number of subsets uh, needed, and easy and intuitive and slightly slower. And second can be uses of a vector, in which like we can store the frequency of the vector with the what with the like relative to the index. Okay, so store all the sums or the faster in practice. So we can use a frequency. We will make a frequency map. We will find sum, and this will like um, store the frequency here, and after that we will just find the answers. You can use vector plus sorting method as well, in which this count duplicates. Okay, so we can see the code as well. Font. Okay, so like this is our this is our proper code that that YouTuber used and he told us. So we will just take the size of array and the target sum, and we will just store the values, and we will call the find result function. And these are the like two main functions that are used here. In the find result function, we will make two frequency map. This is just reserving the size to store different frequency, and like we are just finding some here. We are giving two frequency map and the left and right pointers. Yeah, left and right pointers vector b, and x and 0 is what? 0 is sum so far. Okay, so this is easy. This is just a recursive function, and we are just skipping one element at a time, and in the next recursive call we are just accepting the element. Okay, so 8 in the middle is over. Okay, we have completed 2 algorithms today, and this is a nice thing. Okay. What we can do now is, we can solve this question, or prefix and proof after binary search on sorted array. Binary search. Binary search and monotonic function. Okay, so like this is binary search and answer, that the function true true true, and there will be a transition here, and like I think we can get some sample out of this as well. Okay, let's see what are the next problems. But I think we should solve some questions now, or maybe we can mm, we can study about some projects as well. There are few options. I think we should study about a project. I do have many projects, so Okay. Um, okay. So the next algorithms that we need to study, um, we will study the sieve of prime factor SPF, and we will move to graphs and yeah, we will move to graphs. Yeah, and then we will move to trees. Okay. So okay, 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 okay. Next will be sieve, and then we will move to graphs, and we will do all the graphs algorithm. Then we will move to trees and rest of the algorithms. So if we want, we can like try studying. Okay, okay. This can be a good video. I will watch it tomorrow, not today. Okay, now we will try to okay, okay, we will do this tomorrow. Right now, we will study a project, and then we will okay. Okay. Um, we can study Hoofman coding right now, or we can study a document retrieval system in which hash map, and tries are used. Okay. Hoofman coding will be nice.